Imagine standing on the surface of Earth and looking up at the sun. It seems unimaginably enormous. Its diameter is almost 1.4 million kilometers, and more than 1 million Earths could fit inside it. For most of human history, we believed nothing could be much bigger. Then we started exploring the universe, and we discovered stars so gigantic. They make our sun look like a tiny spark. But among all the colossal stars ever discovered, one stands above the rest. A true cosmic giant. A star so large that it pushes the very limits of what astronomers believe is possible. Its name is Stephenson 2-18, and its size is almost impossible to comprehend. Located roughly 20,000 light-years from Earth in the constellation Scutum, Stephenson 2-18 is one of the largest known stars in the entire Milky Way. If you could somehow place it where our sun is today, everything would change. Mercury?
Gone.
Venus?
Gone.
Earth? Completely swallowed. Mars? Also inside the star. In fact, the surface of Stephenson 2-18 would extend far beyond the orbit of Jupiter.
Think about that.
The distance between Earth and the Sun is about 150 million kilometers. Yet this single star is so enormous that our entire inner solar system would disappear inside it. Even the asteroid belt wouldn't be safe. It's difficult for the human brain to visualize something on this scale. Imagine boarding a commercial airplane capable of flying non-stop around Earth. Traveling at nearly 900 kilometers per hour, circling our planet takes less than 2 days. Now, imagine trying to fly around Stephenson 2-18 without stopping, without slowing down. The journey would take more than 2 centuries just to complete one lap around the star. And yet, despite its unimaginable size, Stephenson 2-18 isn't the most massive star ever discovered. That's one of the strangest facts in astronomy. Size and mass are not the same thing. Our sun is relatively small compared to these stellar giants, but it is much denser. Stephenson 2-18 is what astronomers call a red supergiant. Near the end of its life, it has expanded enormously. Its outer atmosphere is incredibly thin. If you could somehow fly through its upper layers, you might not even realize you had entered the star at first. Its gas is spread across such an enormous volume that, in some regions, it is far less dense than the best vacuum ever created on Earth. It's almost like a gigantic cloud. A cloud so large, it could consume entire planetary systems. But how does a star become this enormous? The answer begins millions of years ago. Like every other star, Stephenson 2-18 was born inside a giant cloud of gas and dust. Gravity slowly pulled that material together until temperatures became high enough for nuclear fusion to ignite. A new star was born. But unlike our sun, Stephenson 2-18 started its life with an extraordinary amount of mass. Massive stars burn through their fuel at astonishing speeds. While the sun will shine for around 10 billion years, a giant like Stephenson 2-18 survives only a tiny fraction of that time. It lives fast, and it dies young. As the hydrogen in its core begins to run out, gravity starts compressing the center of the star. Temperatures rise dramatically. New fusion reactions begin. The outer layers respond by expanding farther and farther into space. What was once an already enormous star transforms into an almost unimaginable giant. A red supergiant, one of the largest types of stars the universe can produce. But here's the incredible part. Astronomers are still debating exactly how large Stephenson 2-18 really is. Unlike planets, stars don't have solid surfaces. Their outer atmospheres gradually fade into space, making precise measurements extremely difficult. Depending on the methods used, the estimated size can change. Even so, every calculation agrees on one thing. Stephenson 2-18 belongs among the largest stars humanity has ever found. And perhaps even more astonishing, it may not hold the record forever, because somewhere in the Milky Way, hidden behind clouds of dust or simply too distant for our telescopes to resolve. An even larger star could be waiting to be discovered. And if that's true, then the biggest star ever found may still be out there. But as enormous as Stephenson 2-18 is, it won't live for very long. In fact, the biggest stars in the universe have the shortest lives. That might seem backwards. After all, wouldn't a larger star have more fuel? It does. But it also burns that fuel at an incredible rate. Imagine two candles. One burns with a small, steady flame. The other is a giant torch. The torch contains more fuel, but it consumes it much faster. Massive stars behave the same way. Our sun has been shining for about 4.6 billion years, and it still has another 5 billion years left. Stephenson 2-18, however, will survive only a few million years. On the scale of the universe, that's the blink of an eye. Every second, it releases more energy than our sun could produce in an unimaginable amount of time. Its core is a cosmic furnace unlike anything in the solar system. Inside that core, temperatures reach tens of millions of degrees. Atoms collide with incredible force. Hydrogen becomes helium. Helium becomes carbon, then oxygen, neon, silicon. One after another, heavier and heavier elements are created. These stars are the universe's factories. Without them, the elements that make up planets, and even life itself, would never exist. The calcium in your bones, the oxygen you breathe, the iron in your blood, were all forged inside stars like these. In a very real sense, every person on Earth carries material that was once deep inside an ancient giant star. But eventually, the process reaches its limit. Fusion can no longer continue. The core begins collapsing under its own gravity. And then, everything changes in an instant. The star explodes. Not as an ordinary explosion, but as a supernova. For a brief moment, a single dying star can outshine an entire galaxy containing hundreds of billions of stars. The shockwave races across space at millions of kilometers per hour, throwing enormous clouds of gas into the galaxy. Those clouds will eventually become the raw material for new stars, new planets, perhaps even new civilizations. Death becomes creation. It's one of the most extraordinary cycles in the universe. And if Stephenson 2-18 explodes as astronomers expect, it will leave behind something equally incredible. Depending on its final mass, the core may collapse into a neutron star, an object so dense that a teaspoon of its material would weigh billions of tons. Or, if the remaining core is massive enough, gravity may continue crushing it until not even light can escape. A black hole will be born. Imagine that. One of the largest stars ever discovered could eventually disappear into one of the smallest and most mysterious objects in existence. It's one of nature's greatest paradoxes. The biggest stars often leave behind the tiniest remnants. Yet the mystery doesn't end there. Stephenson 2-18 isn't alone. Astronomers have discovered other colossal stars, including UY Scuti, WHG 64, and VY Canis Majoris. For years, each of these giants was considered a possible record holder. As telescopes improved, scientists realized that measuring stars of this size is incredibly difficult. Their outer atmospheres constantly expand and contract. Powerful stellar winds blow huge amounts of gas into space. Their apparent sizes can even change over time. That's why the title of largest known star isn't permanent. A new observation, a better measurement, or the discovery of another hidden giant could change the rankings overnight. And that's what makes the search so exciting. Even today, we've explored only a tiny fraction of the Milky Way. Our galaxy alone contains hundreds of billions of stars. Many are hidden behind enormous clouds of cosmic dust. Others are simply too far away to study in detail. Somewhere among them, there could be a star so enormous that it makes Stephenson 2-18 seem ordinary. And if history has taught astronomers anything, the universe always has a way of surprising us. And perhaps that's the most humbling lesson these giant stars teach us. No matter how enormous something seems, the universe almost always has something even bigger waiting to be discovered. For thousands of years, our sun was the largest object humanity could imagine. Today, we know it is just an average star, a yellow dwarf among hundreds of billions of others in the Milky Way. And somewhere out there, stars like Stephenson 2 to 18 remind us just how small our corner of the universe truly is. But even these stellar giants have limits. Astronomers believe there is a point where a star simply cannot grow any larger. If it becomes too massive, the intense radiation pushing outward becomes so powerful that it begins blowing away the star's own outer layers. Instead of continuing to grow, the star starts destroying itself. Nature itself places a limit on how large a star can become. Yet we still don't know exactly where that limit is. Every few years, improved observations force scientists to recalculate the sizes of the largest known stars. Some turn out to be smaller than expected, others become larger, and occasionally, a completely new candidate enters the list. That's because measuring stars this enormous is incredibly difficult. Unlike Earth, a star has no solid surface. Its atmosphere gradually fades into space, making it almost impossible to determine where the star truly ends. It's like trying to measure the exact edge of a cloud. The answer depends on how you define it. That's why the title of the biggest star ever found is always provisional. Stephenson 2 to 18 may hold the record today, but tomorrow, another discovery could take its place. And with new observatories coming online, that possibility is becoming more likely than ever. The Vera C. Rubin Observatory, the James Webb Space Telescope, and future space missions will allow astronomers to study regions of the Milky Way that were once hidden behind thick clouds of dust. They'll discover thousands of new stars.
Some will be ordinary.
Some will be extraordinary. And perhaps one of them will rewrite everything we thought we knew about stellar size. But maybe the most incredible fact isn't how large these stars are. It's what they leave behind. Every atom of carbon in your body, every atom of oxygen you breathe, every atom of calcium in your bones, was created inside stars. Not necessarily stars like our sun, but ancient giants that lived and died billions of years before the solar system even existed. When those stars exploded, they scattered their material across the galaxy. Over millions of years, that material became part of new clouds of gas. Those clouds formed new stars, new planets, and eventually,
Us.
Carl Sagan once famously said that we are made of star stuff. Modern astronomy has shown that this isn't poetry. It's a scientific fact. Without massive stars, there would be no Earth, no oceans, no mountains, no life. The largest stars in the universe are also the greatest creators. Their violent deaths make future worlds possible. So although Stephenson 2 to 18 may one day explode in one of the most powerful events the Milky Way will ever witness, its story won't truly end. Its atoms will continue traveling across the galaxy, perhaps becoming part of another star, another planetary system, or maybe another civilization looking up at its own night sky and wondering about the biggest star in the universe. That's the incredible cycle of the cosmos. Nothing lasts forever, but nothing is ever truly wasted. Every ending becomes a new beginning. Every dying star plants the seeds for countless new worlds. So the next time you look at the sun, remember this. It may seem unimaginably large, but somewhere, more than 20,000 light-years away, there is a star so enormous that it could swallow the orbit of Jupiter without even reaching its full size. And despite all we've discovered, it may not even be the largest one that exists. If you enjoyed this video, don't forget to leave a like, subscribe to the channel, and turn on notifications so you never miss our next journey through the greatest mysteries of space. Because the universe is filled with wonders beyond imagination, And the next discovery could be bigger than anything we've ever seen.